Welcome to another lesson on trigonometric integrals. Here we are going to look at trigonometric integrals of sine and cosine involving even powers. There will be a video on sine and cosine with odd powers, since each of them needs special techniques in integrating. Before we start with, let's revise these half-angle identities from trigonometry. We need to note that cosine squared of an angle x equals half 1 plus cosine 2x. Then the half-angle identity for sine squared x is also half the same thing, but just that here will be negative 1 minus cosine 2x. As far as integration of sine and cosine of even powers is concerned, these two identities are referred to as power reduction identities. This is due to their role they play in integrating these trig functions. They help to reduce the powers to a degree of 1 for easily integration. Let's take the first example. In integrating the integral of sine squared x dx, unlike the integral of sine x dx, which directly integrates to negative cosine x plus c, the square of sine in sine squared x does not have straightforward antiderivative. So we need to express it to a more integrable form. So our integral of sine squared x dx, we should note that but from the half angle identity, sine squared x is the same as 1 over 2 bracket 1 minus cosine 2x. We are going to substitute this in place of sine squared x so that we can reduce the powers for easily integration. So integral of sine squared x dx now becomes the integral of half bracket 1 minus cosine 2x dx, of which we can multiply through by this half and then variable of integration. That will give us integral of half dx minus half integral of cosine 2x dx. So when we integrate half with respect to x, that will give us half x. Then we need to consider this. If we could remember, we generalized that in order to find the integral of cosine of 2x dx, we learned that first you need to integrate the whole function, which will give us minus half already. Then this, the integral of the whole function, will give us sine 2x. Then we differentiate the 2x, which gives us 2. Multiply it reciprocal to the results plus c. And the result for integral of sine squared x dx now becomes half x minus 1 on 4 sine 2x plus c. And that's the result. So take note that for integration of cosine and sine with even powers, you just need to recall this formula. In the same manner, if we are to integrate the cosine of squared x dx, due to the degree, we need to reduce the degree by introducing the half angle of cosine of square x, which we know it to be, but cosine of square x is the same as half bracket 1 plus cosine of 2x. Now, integral of cosine square x dx now becomes the integral of half bracket 1 plus cosine 2x dx. We are going to get the integral of 1 on 2 plus half cosine 2x dx. We will have half integral of dx plus half integral of cosine 2x dx, and obviously this will give us half x plus half, by integrate everything will give us sine 2x. Then we differentiate the function within function, multiply by reciprocal of the results, and that is 1 on 2 plus c. So let's simplify everything. That gives us 1 on 2 x plus 1 on 4 sine 2x plus c, and that will be the result for integrating integral of cosine square x dx. Let's increase the power to. So we have integral of cosine power 4x dx. When it happens where the powers is more than 2, then we have to split the powers, which will give us the integral of cosine squared x all by squared dx. But we know the power reducing identity for cosine squared x. So we say, but cosine squared x is half 1 plus cosine 2x. So we have half 1 plus cosine 2x squared dx, of which we can expand. So when we expand, we're going to get integral of half squared, then 1 plus cos 2x squared all dx. So the constant will give us 1 on 4. Then this, we are going to have 1 plus cos 2x, 1 plus cos 2x dx. So further simplifying, we have 1 on 4 integral of, so this will give us 1, and the same thing by the cos 2x, we're going to have twice of that, that's plus 2 cos 2x, then cos 2x by cos 2x will give us cos squared 2x dx. But as you can see, we need to also find the half angle for cosine squared 2x. Note, to generalize, you should note that if you have cosine squared kx is equal to half 1 plus cosine 2kx. So this simply means that if k is 1, then the half angle becomes half 1 plus cosine 2x. If k becomes 2, then the half angle becomes half 1 plus cos 2 times 2, that's 4x. So in that manner. So in that case, the cosine square 2x becomes half bracket 1 plus cos, then the constant, that is these two, we'll multiply the two over here, and we're going to get 4x. At this particular point, let's substitute this in place of cos squared 2x, and so we're going to get 1/4 integral of 1 plus 2 cosine 2x plus half bracket 1 plus cosine 4x. Simplifying further, we are going to get 1 plus 2 cosine 2x plus 1/2 plus 1/2 cosine 4x. Let's add the constants. Again, 1/4 integral of 3/2 plus 2 cosine 2x plus half cosine 4x dx dx dx. So now let's integrate. We're going to get 1/4 brackets integral of this with respect to x is 3/2x, and integral of this with respect to x, so we're going to have 2. Then integral of the whole thing is sine 2x. Then we differentiate the function within it, that will give us 2. Multiply by h reciprocal, that will be over 2, plus the same thing over here, 1/2. Then integrate the whole thing, that will give us sine 4x. Then we differentiate the function within, multiply by its reciprocal, and that will be by 1/4 plus c. So multiplying through and simplifying, we're going to get 3/8x plus 1/4 sine 2x. This will go to 1 by the 1/4. Then over here too, we are going to have 1/8 by 1/4, and that will be plus 1/32 sine 4x plus c, and that is the result for the integral of cosine power 4x dx. We can also like to try that of sine. So we are going to find integral of sine to the power 4x dx. The same method, you can pause the video to try this, and after that you compare it with my suggested solution. We're going through by the 1/4, we're going to have 3/8x minus 1/4 sine 2x plus 1/32 sine 4x plus c, and that is the answer for that one too. Thank you very much for watching. Please subscribe to the channel and recommend our videos to your friends too. Bye bye.